Hello and welcome to the lesson on graphing from a table of values for linear lines. So as usual, we're going to start with a little warm-up. So this first question, it says sketch 3x plus y equals 6 and sketch 3x plus y equals 9. So two separate lines on the same coordinate plane by first finding the x and y intercepts of each line. So try to think, what do I tend to draw up always before when I am asked to find the x and y intercepts to graph a line? That's right, I drew up this little table. X-intercept, y-intercept. At the x-intercept, what do I write? That's right, y equals 0. The y-intercept, x equals 0. That's always the case. Then just substitute in those values into the equation. So I'm going to start with the green equation first, 3x plus y equals 6. So sub in y equals 0, and then obviously that becomes 3x equals 6, and if 3x equals 6, then x must be 6 divided by 3, so x is 2. So 2, 0 is the coordinates of our x-intercept. Now let's do the same with the same green equation. Don't use the red one, use the green one still. 3, 0. 3 times 0 plus y equals 6. 3 times 0 is just 0, so y equals 6. There you go, we've got our y-intercept is 0, 6. Now let's plot our intercepts. So first of all, I'm going to circle those just to point out that they're the important features which we need to now plot on our graph. And then we're going to connect those. There's the x-intercept, 2, 0. Y-intercept is 0, 6. Now I'll draw a straight line connecting those two. So don't just connect the dots, like continue the line past the dots. That's what you want to do. So I'm about to draw the line very roughly. Now you can see I'm going to make a pale green line. So don't draw what I've done yet, just wait till I've fixed it up a bit. So I've just got to fix it up. So notice how I've extended the line through, and now that's looking a bit better. Make sure your line goes through both the x-intercept and the y-intercept. That's what I've just done there by fixing it up. So that's what you want to draw. And then what should we do before we move on to the next one? That's right, we need to label the line with the equation. 3x plus y equals 6. Now let's move on to the other equation, which I've got in red. 3x plus y equals 9. So again, we just need to find the x and y intercepts. So let's draw up our little table. So remember in the past I sort of had this table partially drawn for you. So this is good practice of how to do it from scratch. At the x-intercept, y is 0. At the y-intercept, x is 0. Now we're plugging into the red equation, 3x plus y equals 9. So make sure to use that equation instead. So I'm doing this one in red. So 3x plus 0 equals 9. 3x equals 9, so x must equal, that's right, 3. So our x-intercept is 3, 0. Y-intercept, now let's plug in x equals 0 to the same red equation. 3 times 0 plus y equals 9. Show your golden step. Y equals 9, because 3 times 0 is 0. 0, 9 is our y-intercept. Again, let's plot our x-intercepts, and we're going to plot our y-intercepts, and we're going to rule a line continuing through them. Don't just join the dots, as I said. Continue the line past the dots. I notice sometimes people are just connecting the dots, but draw through it. So I've done my x-intercept. My y-intercept is 0, 9. So 9's not on our graph, so unfortunately, sorry, our y-axis only goes up to 8. So notice I've kind of put 9 up above 8, about a step up above 8. And now we need to rule a line. So again, wait until I've finished ruling the line completely, because it's always a little bit wonky. I need to adjust it a little bit still. It's just the way that happens when you try to draw it with your finger on the board. There it is. Okay, so that's looking a little bit better now. And notice I am missing something. What have I missed out on my graph? Try to think, what do I need to do still? I'm about to do it, I think. Yep, here I go. Label my line. 3x plus y equals 9. So we've finished question 1a. We're now on to question 1b. So what are we asked in question 1b? Hence, find the coordinates of where the two lines intersect. Have a look up at the graph. Where did the two lines intersect? Do they intersect at all? Bit confusing. They appear to be parallel instead, don't they? So we might want to say there is no solution, as the two lines won't intersect writing very slowly, at any value of x. So basically they won't intersect. You might have noticed that they're parallel as well. That's part B. What's part C? Part C asks us, what do you notice and why do you think this occurs? So to some extent we've already answered what do you notice. So what's something extra that we notice? Something extra that we notice is that the two lines are parallel. So that's what I'm about to write. They don't intersect. It was pretty obvious from part B. As the lines are parallel. And why are they parallel? We'll have a look at the equation. So first of all, this is because, so if they're parallel, what's special about the gradients? So this is because they must have the same, if they're parallel they must have the same, starts with G, probably already guessed it. That's right, gradient. So let's prove, I'm going to prove now that they have the same gradient. To do that we need to look back up at their equations. So let's do a little proof now that they have the same gradient. So we need the equations both in the form of y equals mx plus c. So they're not in the form of y equals mx plus c, but we can rearrange them so that they are, and then prove that they have the same gradient, that they've got the same value of m. So let's take the first green equation. The initial equation was 3x plus y equals 6. Now let's make that y equals mx plus c. So y equals negative 3x, because you've got to subtract 3x from both sides, plus 6. So gradient's obviously negative 3. From the red equation, the original equation was, in red, 3x plus y equals 9. So rearrange to make it y equals mx plus c, y equals negative 3x plus 9. What are the value of their gradients? That's right, both of their gradients are negative 3. So that's what I'm about to write here. Notice that they both have a gradient of negative 3. So that's why they don't intersect, it's because the two lines are actually parallel. So if that's the case, that they both have the same gradient, they're not ever going to intersect because they're totally parallel to each other. So that's interesting. So therefore we say there's no solution when you're asked for the intersection. So now graphing from a table of values. That's what we're about to do now. This is pretty easy, like just substituting values of x into an equation, working out coordinates and plotting them. So this is a very easy lesson where you'll just be using a given equation of a line and construct a table of values and then plot these values as coordinates on a coordinate plane. For example, for the equation y equals 1/2 x minus 1, construct a table of values for values of x from negative 4 to 4 and then plot the coordinates on a coordinate plane. So you might need to draw kind of reasonably small. So you're going to need an x and a y column, x and a y row, so a table, long wide table. Off to the side just marking x and y, and now you have to have the numbers negative 4, negative 3 in the x, because they're saying from x values from negative 4 up until 4. So notice we're increasing by 1, 0, 1, 2, 3, 4. So you might need to write small to fit that in there, sorry. Finish off your table. So notice our x values have followed what the question said, negative 4 to 4. Now we've got to calculate the y values using the green equation in the question. So the y values, what are they? So for example, let's just do a few values with the golden step, the substitution step. For x equals negative 4, let's just show a substitution step, because we don't want to lose marks or anything like that. So good to do a few with a substitution step. So a half x minus 1 is a half negative 4 minus 1, because x is negative 4 in this case. A half of negative 4 is negative 2. Take away negative 2, take away 1 is negative 3. So the y value for that's negative 3. Next one up is when x equals negative 3. Do the same thing again, just sub into your green equation. Y equals a half x minus 1. So y equals 1/2 negative 3 minus 1. Half of negative 3 is negative 1.5, that's right. Take away 1, negative 2.5. So I might need to write quite small to fit that in. Now, what's the next x value? It's when x equals -2. Plug it into the green equation again. We're just going to do a few substitution steps because you can't fit them all in on this page. But it's good to show a few examples. After that, you might see a little pattern. So -1, sorry, -2, -1 minus 1 is -2. Then for x is -1, let's just do one more substitution step. For x equals -1, what do we have? Y equals half -1 minus 1. Half of -1 is -0.5. Subtract 1 equals, I think what it is, -1.5. So you might see a little pattern. Can you see what you're increasing by in that y value row? -3, -2.5, -2, -1.5. And so what I'm pointing at is and so on, because we don't have space to do all the substitution steps. But you might see a little pattern. What are we increasing by each time? That's right, we're increasing by 0.5. So add 0.5, add 0.5, add 0.5. What do we get? Add 0.5 to that. What do we get? Add 0.5 to that. What do we get? And so what I just pointed out, do you see the pattern? So a few little because it's a linear sequence, kind of like a linear graph, it's going up by the same amount. So once you've done a few substitutions, to be honest, you can see a bit of a pattern. If it was an exam or a test, I would show as many substitution steps as I possibly could. Now what you're asked to do is use your graph. Oh no, we need to plot them. So sorry, yep. -4 and -3 I've plotted. -3 and -2.5. Now the next one, go across by -3, go down by -2. Go to -1 and -0.5 is this plot. Now I'm going to plot 0 and 1. X is 0, y, sorry, -1. Now I'm going to plot 1 and -0.5 and so on. All the way up to 4 and 1. So 4 and 1, so we're finished. I've just put a little tick there. So it didn't ask us to draw a line of best fit, so I'm not going to at this point. Just asked us to plot the points. Sometimes they might ask you to draw a line of best fit, so just be careful to read that in the question. But there is an extra part to this, so a line of best fit is actually potentially going to be helpful for that. Use your graph to find the coordinates of the X and Y intercepts of the line. So to be honest, you can see them just from the plots. What's the X-intercept? Have a look. That's right, it's at 2. What's the Y-intercept? Have a look. And it's at -1. But notice they want them in coordinate form. So I'm going to do a line of best fit at this point just because it kind of looks nice, helps you to see the X and Y intercepts maybe. So I'm going to do the X-intercept first. Notice that they want them as coordinates. They want the X and the Y intercepts as coordinates. So don't just write X equals Y equals. If they want coordinates, write the bracket with the X and Y coordinate. So from the graph, we can see that the X-intercept is at, what's the coordinates of the X-intercept? Looking at the graph. So coordinates, reminding you, has to be brackets 2, 0, x, y, and the Y-intercept, what are the coordinates of that Y-intercept? Is at, have a think, brackets 0, -1, correct. There you go, so you've answered it all. So as you can see, plotting graphs from tables is pretty easy. That's why we've kind of popped it in as a little afterthought. So we've dealt with the more difficult questions, topics in the earlier lessons, and now we're just finishing up with some nice, slightly easier ones. And that's the end of the lesson. Thank you for watching.